Welcome everybody to our webinar about the latest GEDO IMS release as of May 2020. My name is Kai Naumann. I'm the Senior Product Manager responsible for GEDO IMS. I'm placed in Wiesenthal here in Germany. And I'm, as I said, the Product Manager for GEDO IMS, but also partly for GEDO Office when it comes to GEDO IMS related issues. When we talk about GEDO IMS, I just want to give a quick introduction about what IMS means, or IMU in this case, Inertial Measuring Unit. This means that we have a multi-sensor system that consists of 3 rotation measuring units and 3 translation measuring units to measure the 3D trajectory of a body in space. Inertial in this case means that in a certain frame of reference, a body with a 0 net force is acting upon as if it does not be accelerated. The body is at rest or moving at a constant velocity. GEDO IMS was released on April 21st in version 1.301. We currently already have an update 1.302. And GEDO Office is the latest version 2.761, released April 21st. The topics I'm about to talk today cover a few issues that you might be interested in. One is dealing with the GEDO IMS measuring options for absolute referencing. We have different modes how you can measure the reference points. We have added a new functionality, including the total station. So I will give you a comparison of those different options. So how does Profiler behave versus total station? We have several different methods of using a total station, using different adapters attached to the trolley. I'm also talking about project coordinate definitions and then their verification. Another feature that has been implemented is the new measurement mode relative track geometry that I'm about to talk. We have a new in the software live view for clearance. We also added an option about how to calibrate the odometer. And of course, at the end, I will talk about some additional features in GEDO Office. So absolute referencing. The IMU sensor on the trolley measures the relative track geometry. The IMU has certain drifts, unfortunately. So the IMU measures angles and accelerations, but even if the IMU stands still, there would be a drift being applied to the sensor. So after a certain time, even if you stood still, it would seem as if you would have walked or moved. And this is called drift. And this drift has to be somehow compensated. And we compensate the drift by measuring reference points. So the reference points do not only provide an absolute position to the IMU measuring system, but also adjust the drift. So every now and then you have to measure reference points. These reference points can be either defined as coordinated points in the center line of the track. You could use GNSS, where you would use the GNSS coordinate and by that adjust the drift. Of course, GNSS is not the most accurate method, but if you are fine with a centimeter accuracy, then this is good enough. Or third option would be to measure reference points beside the track being defined by either catenary poles where you have a certain mark attached to it, or points marked in the ground. So when you measure those points, you can either use a profiler, measure the distance and height offset to this reference point at that specific chain edge. And now with the new software version, you could also use Total Station S series to measure the distance and height offset to that point. An option that we already had in it was to do a resection with the Total Station by using Trimble XS. So Trimble XS would run on the same control unit, and we would just use the coordinates that you've defined with the resection inside of GEDO IMS as well. So now I want to give you an overview about the advantages and disadvantages of those two measuring devices named Profiler or Total Station. Big advantage of the Profiler, as you can see it in the bottom picture, it's a low budget device when you compare it to Total Station, of course. So it's probably about a third of the price of a S9 Total Station. It's very, very simple to use, so you actually don't need any kind of surveying specific knowledge or experience to use this profiler unit. It's basically a laser pointer, a disto measuring the distance, and all you have to do is aim it towards the target and hit the measure button. That's it. The software includes a field calibration procedure. So when you think about a Total Station, you need to calibrate it every now and then. And this is part of GEDO IMS also. And it's pretty simple. You only have to aim one target in 2 phases, and that's it. The DR performance is very strong. When I compare it with a Total Station, it's massively much higher performance, especially when you have gray walls or very close targets. Then it's pretty difficult to aim to it with the Total Station. Not the aiming, but the measuring takes you ages. So no targets are required. You don't need any reflective additional target or anything like that. You can just shoot towards the point of interest. And another advantage of the Profiler is that the trolley is always positioned perpendicular to the point, whereas when you use a Total Station, you already have the horizontal angle that you can rotate the Total Station around. On the disadvantage side, the Profiler can only be used for this survey task. So if you use the Total Station, you can easily go to a customer who already has a Total Station in his equipment, or you can tell him, well, if you invest into a Total Station, you can also use it for other survey tasks, which is not possible with this Profiler unit. Aiming with a laser pointer might be challenging. That's true, because when you can only rely on the laser pointer, on the visible laser pointer. So when you have surfaces that are kind of dark or red, or any kind of obstacle that is further away than a certain distance, or the sun hitting directly into the point of interest, then it's really difficult to see the laser pointer. What is an advantage that the trolley position is always perpendicular to the point can also be a disadvantage, because you have to stand exactly perpendicular with the trolley perpendicular to the reference point. Whereas with the Total Station, you have a kind of a certain area where you can place the trolley. The biggest disadvantage is when it comes to height accuracy, because the height accuracy when you use a Profiler is limited by the inclination sensor that is mounted on the trolley. So therefore, the maximum distance is somehow limited to 10 meters. So to outline this a bit more, I have used all my skills in drawing in this presentation. So my apologies for this. The height accuracy almost only relies on the accuracy of the inclination sensor, because to adjust the vertical angle, we need the information by how much the trolley is inclined in the track. The inclination sensor has a certain accuracy. This is around half a millimeter based on 1.5 meter cant. So you can easily estimate that when you now measure a point in, let's say, 10 meter distance, then this half millimeter accuracy will increase up to 3.5 roughly millimeters in 10 meter distance. And this is always plus minus. So in worst case, you can have a range of 6.5, 7 millimeters when you measure a point in 10 meter distance when it comes to the height accuracy. On the other hand, if you use a total station within a tri-brake, a specific tri-brake that is used on the trolley, that you can level the instrument and then use the internal compensator of the total station, you can measure very precisely the height because you are totally independent from the inclination sensor measurement. So the same advantage, disadvantage list I want to go through for the total station. On the one hand, we have standard survey equipment. So this can be also used for other surveying purposes like stakeout work or machine guidance or whatever. We can use an autolock mode with prisms, which makes it much easier to aim towards targets that are further away from the track because of the autolock functionality. We could also use DR mode with a laser pointer, so it's kind of a more flexible approach. But as I said, when the obstacle is very close, the DR of the total station is not so good. We have several total station adapters. I will come to this later in my next foil. And yeah, non-perpendicular composition is corrected automatically. So you don't actually have to stand exactly perpendicular to the reference point. We offer a range of plus minus 1 meter around the reference point in this case. On the disadvantage side, yeah, high-level instrument increases system price. So what could be an advantage when the customer already owns a total station can be a disadvantage if he needs to invest into the total station instead of a profiler because of the higher price. It also, the trolley gains some weight by the total station and the tri-brake or adapter used. And yeah, the DR performs not so well. Talking about the adapter options, we have offered 3 different kinds of adapters. We have a so-called fixed total station adapter, where the total station is mounted directly onto the trolley without leveling. So then the measuring principle would be the same as for the profiler. So no leveling would be required, but this also means that we have the same height problem as with the profiler. On the other hand, we offer those 2 tri-brakes that can be leveled, a manual tri-brake that you might already know from the GEDO Forces twin trolley system, and the automatic total station dry brake. So when you use the system with a fixed adapter, biggest advantage would be small weight. And as there is no leveling required, the measurement performance is very high because there's no leveling required. On the disadvantage side, again, high accuracy issue, as I already stated, we are then already again dependent from the inclination sensor as with the profiler. And yeah, this adapter can only be used in this GEDO IMS system. It cannot be used in any other GEDO application or any other application as well. Whereas when you use the manual dry brake, as already stated, high accuracy is only limited to the accuracy of the or angle accuracy of the used total station. And it's also the standard dry brake for GEDO Vorsys system. So a customer who already owns a GEDO Vorsys system could use this equipment together with GEDO IMS as well. Disadvantage, manual leveling needed. It needs some experience, but I think after a few approaches, normally customers get into it. For those customers who don't get into it, we also offer the automatic dry brake, which is powered by 12 volts and automatically levels itself. Again, same height accuracy. Once the compensator is in its working range, then you're only limited by the angle accuracy of the total station. Dry brake can also be used for the Vorsys system. On the minus side, dimensions and weight. So the automatic dry brake is very, very heavy weighted. It's, of course, the most expensive adapter that we offer. It's almost 4 times the price of the manual dry brake. So it's up to the customer what he prefers. We have the experience that once you became more experienced with the manual dry brake, you are much quicker than with the automatic dry brake, because the automatic dry brake is always limited to the motors inside of the dry brake, which are very slow because they need to work very precisely. So the speed is very slow compared to a manual method. On the minus side as well is when the dry brake dies for whatever reason. So low power consumption or something breaks inside, you cannot work anymore. It's impossible. Whereas a manual dry brake will always work. Summary. Comparing those 2 devices, namely profiler and total station with those 3 adapter methods, when you compare them against each other, and we try to come up with 4 issues: ease of use, ease of handling, reference points at wider range, and the measure performance when it comes to speed. You can, I guess, easily see from this green and red dots where the strong and weak points are. So ease of use, of course, the profiler is the easiest device to be used. You don't need any surveying background at all. Whereas when you use a total station, you at least have to kind of know how it works, how you have to aim, how you have to rotate the horizontal and vertical angles, how you can zoom or focus. And the fixed adapter is easier to use when you compare it with a manual dry brake, because you don't have to level it. On the other hand, the auto dry brake does this by itself. But if you go one line further down and you go into ease of handling, then manual dry brake and auto dry brake are a bit weaker than the other two because the weight is much heavier when you use the auto dry brake and the manual dry brake. That's why we put here ease of handling. It's mostly when it comes into weight and handling of the trolley. Not so much the software, but the trolley itself. Reference points at wider range. There, of course, the biggest advantage is with the dry brakes, manual or auto, doesn't matter, because of the height issue when it comes to points that are further away than, let's say, 5 meters. And the measurement performance, after all, is the highest when you use the fixed adapter, followed by the profiler. Fixed adapter with the total station is higher because you can use a prism and use autolog, so the aiming gets much faster than with a profiler, where you sometimes have issues with finding the right spot with the laser pointer. Other new features. As with the latest update, we offer now a so-called here button in the software. When we initialize the IMU needs to roughly know where it is on the planet. So we need to provide a project coordinate for it. So we have to provide it with a latitude and longitude. And we use the internal GNSS of the control unit, namely the TSC7. And so you can press the here button and it will jump with the latitude and longitude where it actually is now. And every time you start the project, this project location will be verified by using the internal GNSS again. So once you are outside of the valid area, then you will get a message that you have to create a new project coordinate. We now offer a new measurement mode named relative track geometry. Up until then, we only offered absolute track geometry measuring. Relative track geometry measuring means that you have no design, no alignment, no reference points, which means that you probably only measure curvatures. And by measuring those curvatures, you can then estimate where areas of straight lines are or arcs are. And you can use this to actually create a best fit design for the track using our software GEDO Nova Track, and then provide data to the tamping machine as well. Of course, only in a relative frame, but for measuring a straight line or an arc, it doesn't matter if you are in an absolute reference frame or not. We have introduced live view for clearance, as you already know it from GEDO Scan. So it's now available in GEDO IMS as well when you use a scanner. In the field, you get a live comparison with a 2D clearance profile that can be defined by a simple DXF file, providing the local rule for clearance profiles. This is also supported not only by the scanner, but also by the profiler. So this frame will also be visible in any kind of topo measurement that you do with a profiler towards any target beside of the track. And you can instantly see if you have any intrusions that are marked red when they are inside of the clearance profile. And then you can provide this as a area that has to be somehow maintained in a certain way. We now offer odometer calibration. Odometer calibration means that all information that when we create the trajectory out of the IMU measurement. We use an odometer wheel to know where we are on the track, and this odometer has a certain scale factor. And when this is delivered, normally the odometer has been calibrated, but over time it can pick up dust. It can, get older. The scale factor might change because of the diameter of the odometer wheel being due to change. So when you measure with the IMS system at the end of each survey, at the end of each chord, you get a comparison how well the odometer distance fits into the distance that has to be defined by the reference points you measured in between. And by that we can measure calculate a scale factor. In case of this screenshot to the left, it's 100.2%. So this means on 100 meters, the odometer went 20 centimeters wrong. And if you experience that this scale factor is not 100%, but it's quite constant, like in this middle screenshot that is coming out of GEDO Office, you can see it's always in between 1.003, then it might make sense to calibrate the odometer. And then we have a feature in the calibration menu of GEDO IMS where you can set a new odometer scale factor, and from then on this scale factor will be applied to all odometer measurements, and then this factor should be 1 again. So of course in GEDO Office some features or functionalities had to be added as well. Most importantly, the support for the total station measurements. The look and feel and the workflow is exactly the same as for using the profiler, only some additional parameters have been added, like prism constant or the tri-break that you used, so that if you made a mistake in the field, you can edit those parameters in the office later on. Some massive changes have been done in the transformation node in GEDO Office. So in the transformation node, it's now possible to add design or measurements by either drag and drop, or now you can also import an existing trajectory from an external file and put that into a transformation node. And by that, you can now compare design with a design. You can compare measured trajectory with a measured trajectory. Maybe you have different epochs and you want to compare those two epochs with each other. You can now do that. And the offsets will be the ones between those two measurements. And of course, you can still do the same as before, like you compare a measured trajectory against the design. Another new feature is enhanced trajectory analysis, where you can decide between if you want to convert points on the complete line in a constant grid, like before. But now you can also choose that you can have a constant grid between individual start and end chainage. And you can define specific chainage values that come from an external point list. So when you have certain chainages that are actually point of interest, then you can define them in a list, a simple text file, import them into the transformation node, and then the transformation will be performed only at those specific chainages. This is sometimes important when it comes to sleepers in slab track. where you have to measure normally exactly at the sleepers. The sleepers have a certain change, and the contractor wants to know the lift and slew values, or let's say the offsets, at that specific chainage values. Another new feature is that you can now see the topo points in the transformation as well. Up until now, we only transformed the line points or the center line points. Now you can also see the topo points. And if you've measured some, also the reference points, or this is also new now, you can drag and drop a reference point list with easting northing elevation to a transformation node, and it will give you station or chainage lateral and height offset. The direction is also possible vice versa, so you can have a list with a chainage, lateral offset and height offset, and it will give you easting, northing and elevation. So this is basically it. If you have questions, type them into the chat. If you want to get in touch with us directly afterwards, then simply send an email to info@trimblerailway.com, and we will be really eager to answer them. Thanks for paying attention.